All right, so we're going to talk right quick about factorials. Not right quick, but we're going to talk about factorials and how to code them and like how recursion works. So usually the first time you learn about recursion, it's a lot of times with factorial because it's a function that a lot of us know and it kind of makes sense. So recursion or like factorials are like if you have like 6. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, right? And if you were going to explain it to someone, you'd be like, so whatever 6 factorial is, you start at 6 and you keep decreasing until you get to a 1. So from a programming perspective, you can kind of do this as a for loop, you could say, for some index going from 1 to n, x is going to be the previous number times I. And say like x would start at 1, so it starts at 1, 1 times 1, and then is 1, and then 1 times 2 is 2, and 2 times 3 is 6, and you kind of go all the way up like that. So that's a factorial function if we were just doing something like with a simple for loop, so you can totally do it that way. However, since it's a relatively easy concept to understand, maybe not this as much, but this is pretty straightforward, you kind of think about, well, how can I explain this to someone without using a for loop? And the way that you might do it is you say, okay, so basically what you're going to do is you are going to say, well, 6 factorial is the same thing as 6 times 5 factorial, right? Because if I take this right here, 5, that's just 5 factorial. And 5 factorial is the same thing as 5 times 4 times 3 times 2 times 1, which is actually the same thing as 4 factorial. And you see where I'm going here. So 4 factorial is 4 times 3 times 2 times 1, which is actually the same thing as 4 times 3 factorial, 3 times 2 times 1, which is the same thing as 2 factorial, which is the same thing as 1 times, well, 2 times 1. There we go. 2 times 1. And then here we stop. Like this. Woohoo! So there, you can see the whole thing. Oops, except I moved it. All right, so you can see the whole thing is basically, and this is the idea of what recursion is you define a function in terms of itself until you end up at a stopping point, I guess. So, yeah, there we go. There are going to be some of you who are like, but technically that you don't stop at a 1, which is true, I guess. So officially, this is 1 factorial, which is equal to 1 times 0 factorial, and 0 factorial is physically defined as 1, so you stop here. Although I always thought that was kind of dumb, but all right, we'll just go with that because somebody's going to get all upset about it. All right, so the idea is that you're going to go all the way down. Yeah, I still don't like this. Let's just stop at 1 because what are they going to do? They're going to take us out. We'll just say whenever we get to 1, we stop. All right, so the idea would be that we'll say, okay, so if I'm going to do a factorial, I would say, okay, so if I'm trying to find the factorial of, I don't know, like I'll just say x. If I'm trying to find the factorial of x, it would be equal to x times the factorial of x minus 1, right? Does that kind of make sense? So the factorial of x is equal to x times the factorial of x minus 1, and then you keep going until x is equal to 1. Then you say the answer is 1, and you work backwards. Okay, so the idea would be, all right, so picture, we do this in class sometimes where we're all sitting in like a little happy circle, 2, 3, 4, 5, 6. And this person's job is to figure out what 6 factorial is. And they're like, I don't want to work that hard. So I know that it's 6 times 5 factorial. So they say, hey, dude, what's 5 factorial? And they're like, well, it's 5 times 4 factorial. Ugh. Hey, dude, what's 4 factorial? Let me draw these as, yeah. So that's his job, is to find 4 factorial. He's like, I don't know. It's something times 3 factorial. And so, oops. So this dude's like, okay, what's 3 factorial? You kind of see where we're going with this. And he's like, I don't know. It's 3 times 2 factorial. What's 2 factorial? He's like, I don't know. It's 2 times 1 factorial. What's 1 factorial? And then this person's like, this is ridiculous. The answer is 1. And he goes, oh, awesome. So it's 1 times 2. So that's 2. And he goes, oh, awesome. That's 3 times 2. So that's 6. Oh, awesome. That's 6 times 4. So that's 24. Oh, awesome. That's 5 times 24, which is like 120. And then they're like, oh, so 6 factorial is 6 times 120, which is, I don't know, 6 times 120 is 720. 720, that's the answer. So what happens is in recursion that all these people are put to work, right? So there's like 6 open instances. So like this guy is waiting for his answer while this guy is asking for his answer, who is still waiting for his answer, who's still waiting for this answer. So once this person answers, then they work backwards, and then, here, let's do it this way. Stdoops is waiting for Stdoops, and this one's waiting for this one, and this one's waiting for this one, and this one's waiting for this one, and this one's waiting for this one. So whenever one gives his answer back, then it is done. It's not an open instance anymore. And then whenever 2 answers 3, then, that goes away, maybe if we're lucky. All right, and then whenever 3 answers 4, that one goes away. And whenever 4 answers 5, then 4 goes away, and then this one goes away, and then finally the last instance of the called recursion goes away. So hopefully this kind of makes a little bit of sense, and now we're just going to go programming. Okay, let's go do this in Matlab. Okay, so I'm doing this in Matlab, so I'm going to create a script. So in Matlab, whenever you're creating a function, and you don't necessarily, so when I'm doing these videos, I don't necessarily expect that you know how to code, because that's not the point of this. This is the point to kind of understand the concept of what recursion is. So I'm going to start with the word function, because this is just how Matlab happens to work. Start with function, and my answer is going to be, I'll just call it my answer, I'm going to call it my factorial, and the input will be n. So, like if I'm trying to find 6 factorial, then n would be 6. So one way to do it is to start making a factorial function or any kind of recursion function by just starting with the base case. So the base case for a factorial function is that if n equals 1, then my answer is equal to 1, because 1 factorial is 1. All right, so I'm going to save this, and whenever you're saving this, it should save as my factorial. This isn't specifically a Matlab tutorial, but just to kind of let you know. So this is my factorial. I see it, my factorial here. And that way, if you see it in black, like if it's in a subfolder of something else, it's not going to work. So you want to actually see it right there. So I have my answer is my factorial. So I can kind of test it down here in the command window. If I say my factorial of 1, I get the answer, which is 1. I'm going to format compact for this right quick. So my factorial 1 gives me the answer that I'm looking for. Okay, so I have the base case working. And a lot of times with the recursion, that's a good way to start with programming. If you're having a hard time programming recursion, is start with the base case. What happens whenever you're done? I know that I'm done whenever n is equal to 1. So if n is not equal to 1, I could say, then what do I do? Okay, well, my answer is going to be equal to, and if I kind of look at my picture or the notes from a minute ago, I've got that it's going to be my factorial of n, or x, or whatever, is going to be x times the factorial of x minus 1, or n minus 1. So it's going to be n times the factorial of n minus 1. All right, I'm going to unsuppress my output so you can kind of see this happening. And it's kind of weird, but believe it or not, that's it. Like, that's the whole thing. And that's the weird thing about recursion, is a lot of times if you do it right, it looks like you've accomplished nothing. Okay, so if I ask for my factorial, I can't spell, of 1, it's still going to come back as 1. But now if I ask for my factorial of 2, notice how it's going to say my answer is 1, then my answer is 2, then it comes back with a 2. I'll show you a little bit more. Let's make this go away. Okay, so if I do my factorial of 5, you're going to see, okay, first the answer is 1, then it's 2, then it's 6, then it's 24, and it's 120. Oh, we were doing 6 before, weren't we? So my factorial of 6. So it's 1, 2, 6, 24, 120, 720. Then this is the return of the answer of 720. And those are the numbers you saw here, 1, 2, 6, 24, 120, 720. Now, if you want to kind of understand a little bit more of what's going on, rather than you know, just simply not suppressing your output, you could actually put in some, I'll do an fprintf here. You can actually put in some, I guess, display statements that says something like, in my factorial where n equals this, and I'm returning an answer of, I think that'll work. And then we're going to put in n and my answer, except I can't spell. And in fact, I can just put this, let me see where I want to put it. I'll put this one there, and then I'm going to put this one here, and put the same thing there. Then I'm going to put a new one here, maybe. I'm kind of making this up as I go in case it's not deeply obvious. And I'm going to say in the my factorial where n is equal to this, and I'm about to find out what my factorial of is. And oops, and n and n minus 1. All right, we'll see if that works. Okay, it might not. We'll see what happens. Oh, there we go. All right, so let me CLC clear. Nope, CLC clear, and then my factorial of 6. So I wrote these out so you could kind of see. Okay, so what it's doing is it's like, okay, I'm about to find out what factorial of 5 is. But then notice that it's not printing this right away. So you might expect to see this and then I'm returning an answer, but it's not returning an answer because it's calling the factorial function a second time. So it's in my factorial and I'm about to find out what factorial of 5 is. Oh, I'm in where it's 5 and I'm about to find what 4 is. Oh, it's at 4, I'm about to find what 3. I'm at 3 to find 2, I'm at 2 to find 1. And now it goes, I'm where it's 1, and now I'm returning an answer of 1. And then you see, oh, now I'm returning an answer of 2. So actually this thing and this thing go together. This one and this one go together. This one and this one go together. Wait, I think I'm getting off. This one and this one go together. This one and this one go together. And then that. If you want to kind of see, let's see, how could we do this? Let's put another %d here. %d, and then over here put another n, just to make it super clear, maybe super clear what's going on. So you see that the 6 and the 6 are from the same instance of the what's-he-do's, are in the same instance of the call, of the recursive call. Yeah, I guess I can't think of another way to kind of show you, but basically what you're seeing is at this time, when I'm right here, the 2, the 3, the 4, the 5, and the 6 are all open functions waiting for an answer. And you can tell this actually, so let's just say I'm going to be super obnoxious. And I'm going to do my factorial. I might have to play around with this to get the right answer. 7,000. All right, so if I do this, okay, the answer is infinity. That's good to know. There might be a way. Let's see if I can kill my computer. 7 oops. Oh, wow. No, it's just hanging out, doing its thing. Oh, there we go. Okay. So basically, I have no idea how many of those I did, but it was doing a pretty good job. It was like pretty awesome. And then it's like, oh, yeah, this is probably an infinite recursion. So even though technically I am 100% like allowed by science to ask for whatever that was, 7 million billion, 70 billion? Yeah, 70 billion. So it's asking for the factorial of 70 billion. And it's like, are you kidding me? So basically what happened is the number of open factorial calls was exceeded. And this is one of the differences, I think, between like good programs or like more, like the more expensive versions. So like I have a certain version of Matlab, and I might not have as many open calls to memory as people in other who have other different versions of Matlab. And so if you're wondering why like the fancy industrial version of Matlab is like $10 billion a seat and the student version is like $99, that's just because the version that I have, or the version that you have, I I don't have a student or an industrial, I have something in between, just doesn't have the capability. So if you're at home, you might get it might kind of stop working at a different spot. And that's just because you have a better, so we're getting close to finding out what the recursive limit is, but you probably have a different capacity, just kind of depending on maybe it's your machine or the type of Matlab that you bought, or even the edition. So like the 2020 version might be different from the 2023 version of Matlab. Okay, and then because I'm obnoxious, I always want to know like exactly what can my computer do. So if I do my factorial of 69,000, whatever I just wrote, hold on, totally forgot, but it'll show me in a second. Okay, I did my factorial of 69,899. Now, it didn't give me what I would call a good answer because it told me the answer was infinity, and but at least it ran. So this is a different kind of error. But see, I have 69,899. If I go 69,900 and I run it, I think that's going to be the last straw. It's like, just no. So it got all the way down to the second to last recursion, and it was like, no, you're dumb. Stop making me do this. And so it didn't actually get any answers at all. It was always about to call my factorial, and it just never got there. Yeah, so see, it's just trying to call, and it's getting all the way down. It gets to n equals 2, and this is like when you're like, just try one more and you would have finished it. But it's like, no, I quit. So again, we're just trying to look at different concepts of programming here, and the factorial is an interesting little thing where recursively, I can't solve for x is equal to whatever that number was that I just did, 69,900. However, if I put it in a for loop, for when I equals 1, 2, that, blah equals blah times I, it's going to come up with an answer eventually, but that answer is going to be infinity, but it'll at least run. And this is why we... Thank you. That's not what I meant to do. Yeah, see, it's already infinity. This is why you study discrete math as a computer scientist, and so you can kind of understand that there's different ways to program stuff, and you're going to get different answers and different errors. You know, so you might have a computer that can handle bigger numbers that can't handle the total number of recursions, or you might have kind of an opposite problem, and how you're troubleshooting those on a programming level is just kind of depending on what system you're working within.